In this lesson, we're going to be practicing writing rational exponents as radical expressions. So what is a rational exponent? A rational exponent is the idea of a rational basically means it's going to be something that can be written as a fraction. So you're going to see your exponents now became fractions. So how do we deal with that? Well, the denominator in your exponent is really just going to represent the root that you're dealing with. So this is your base, still your base. Whatever the denominator is, that's the root that you're talking about. And the m is really the exponent. So you can write it one of two ways. It can look like this, where the exponent is on the inside of the root of the radical sign, or you're going to take the nth root of whatever you're dealing with, and that whole piece will be raised to the nth power. And it just kind of depends on what the situation is. If you're dealing with variables, this is most likely how you want to leave it. If you're dealing with numbers, this is going to end up being a little bit of an easier process. So let's do a couple and kind of see what we're talking about. So we're going to be writing rationals. We're going to take something that's irrational. We're going to use radicals to help simplify it. So directions may say simplify. So let's see what we got. So if you have 8 to the 2/3. So there's two different approaches to this. One is you can write this as the cube root of 8, and that value is going to be squared. You could put the square on the inside, but then you'd have to square 8 and then figure out what the cube root is. You get the exact same result as if you cube root the 8 first, which will make it smaller, easier to deal with, and then take that value and square it. So the cube root of 8 is 2, and then we still have the second power to it, so that becomes 4. Now a little bit of a different approach, depends on what you're doing, also is taking this 8 and realizing that it is just a bunch of 2's, so it's really 2 to the 3rd power, and then so that 8 is 2 to the 3rd power, and then we can apply the 2/3 power to it. And this is a power to a power, so we can multiply these two together, and this will actually simplify because you'll take, you could put this over 1, multiply the numerators, multiply the denominators, or you can take 3 divided by the 3 times 2 is still going to get you 2 to the 2nd power, which is 4. Alright, so two different approaches. This is probably more common of what you'll see, but this approach also works. So let's do another. So if you have 81 to the negative 3/4. So we're dealing with the 4th root of 81, and that is going to be to the negative 3rd power. So 4th root of 81 is 3 to the negative 3. And negative exponents do not create anything other than it just flips it, doesn't make negative numbers. So this becomes 1 over 3 to the positive 3, which is 1 over 27. Now if you wanted to kind of use this approach, 81 is just a bunch of 3's, and so it is 3 to the 4th, and then you still apply your negative 3/4 power to it. 4 divided by 4 is 1 times negative 3. Oops. And you'll get to the exact same position as you were in the other one. So that'll still become a 1 over 27. Right? So here's another one. So if you have negative 8 to the 2/3, we're looking at cube rooting. Based on the denominator, we're cube rooting negative 8, and we're going to take that value and square it. So can we cube root a negative 8? Yes, it consists of negative 2 times negative 2 times negative 2, which is then negative 2 to the 2nd power. Negative 2 to the 2nd power is just positive 4. All right. So if we do another one, if we take negative 16 to the 3/2 power, so that is equivalent to a square root. So we are square rooting negative 16, and then whatever that is, we'll cube it. But this, and it depends on where you're along, if you've dealt with imaginaries or if you haven't dealt with imaginaries. If you haven't dealt with imaginaries, this is a non-real, because you can't come up with two numbers that are going to multiply to get you a negative 16. It's going to be a positive and a negative multiply together, but they're not the same. So depending upon where you're at, that's a non-real. If you can square root and you've done the imaginaries, then you can square root this to get a negative, to get a 4i, and then you can raise it to the third power and continue. So it depends on where you're at. So number 5. So what if the negative is not inside the parentheses? Well, this time you're square rooting 16, raising it to the third power, and that negative sign is going to be applied after the fact. So you square root 16, which will get you 4, and then you'll cube that, and that's going to get you 64, and the negative gets applied at the very end. All right? So what if we have a little bit more complicated ones? So we'll throw some fractions in and see how that messes with it. So, number 6. If you have a fraction, 64 over 27 to the 2/3. Basically, you just have multiple problems within one. You are dealing with the cube root of both 64 and 27, so you can write it individually as the cube root of 64, and then that'll be squared over the cube root of 27, and that'll be squared. So we just have to do each piece individually. So the cube root of 64 will give us 4. And then we'll square that value. Cube root of 27 is 3. And we'll square that value. So that'll get us a 16 over 9. And that's it. Now as you go, you're always looking to try and reduce your fraction to its simplest form. So, but at the very beginning, if you can't reduce this fraction, you're not going to be able to reduce this fraction either. So if you are going to reduce, I would try and do it at the very beginning, unless you recognize right away that they are perfect cubes, and maybe you don't want to mess with that because it may make it a little bit more complicated. So you have different paths, and you'll get used to them kind of as you go through them. So what if we take another fraction, 25 over 36, and raise it to a negative 3/2 power? Well, a couple different ways that this negative exponent, just like up here, the 2/3 applied to both of them, well, the negative 3/2 is going to apply to both of them. So you could do that, but negative exponents, all they do is that it's going to move the 25 down and it's going to move the 36 up. So we can do a little bit of a shortcut, simplify the process, is let's just switch the 36 and the 25 to begin with, because that's what the negative exponent's going to do anyways, and then just raise it to a positive 3/2. Because you're still going to be square rooting and then cubing whatever the values are. So now we've just kind of reorganized it, made it a little bit easier. So we're square rooting 36, taking that answer and cubing it. We're square rooting 25, taking that answer and cubing it. So square root of 36 is 6, and then we'll cube that. Square root of 25 is 5, and we will cube that. So 6 cubed turns out to be 216, and 5 cubed is 125. All right, so those are ones that all work out really nicely. So how do you deal with values that don't work out as nice? And sometimes there's not much to do. So if you have 5 to the 2/3, then you really can start off by rewriting it as you're cube rooting the 5, and whatever that value, you'd square it. Or since we can't actually perform this operation because the cube root of 5 is going to be a decimal, and then you're going to square the decimal, You could also just write it as then 5 squared. If you can't perform it, that's probably one of the more common ways of writing your answer. But really they're equivalent. And so you could plug it into a calculator, see what the calculator is going to give you. All right, so if you have some variables. If you have variables, x to the 7/5, how do you deal with that? Exactly the same. So you are dealing with the fifth root of x, and since we're not going to be able to do the fifth root of this value, since we don't know what it is, we'll just keep the 7 on the inside. You could just as easily kind of rewrite it like this, where you had a 7 on the outside, but that's probably the most common way to see it written. All right, so what if you have multiple pieces and they have a power to them? Well, start off with 2x, the cube root of 2x squared. And that's it. So everything that has the power on it is really everything inside the cube root. All right, what if we have x plus 5 raised to the 2/3? Well, exponents don't distribute over addition and subtraction. They don't apply to both. So we are just rewriting it as the cube root of x plus 5. And since we can't cube root anything, we'll apply the second power to the inside. All right, so let's see, what if we have a negative 2/3 power? So b to the negative 2/3. Well, first thing is we have a negative exponent. That negative exponent is going to bring that piece down. So it'll become a positive 2/3 once we bring that down. And then we're applying it exactly the same as we are with all the others. So it's going to be 1 over the cube root of b squared. All right, and that was writing rational exponents as radical expressions.